arrays. So we're splitting arrays into two parts. There's kind of like the intro part, which is this one, and then we're going to dive a little bit more deeper into arrays and kind of what are some of the more powerful or useful functionalities with it. So this one I might go through a bit faster just because a lot of it should be review. We've actually done problems with some of these categories already, but definitely let me know if any of these are things that are kind of like completely off the wall in terms of things you haven't seen before. So the setup for arrays, obviously, arrays is synonymous, at least kind of in human speak, with lists, right? It's just a way for you to preserve a list of different things. Because it is a list, one of the main reasons people use arrays is because ordering is very important, right? We saw that earlier today with the calendar problem where the months had to be put in the correct order, because if they weren't put in the right order, then when we try to access the list and we were pulling the 6th item or the 7th item, it would actually give us not the results that we wanted. The other thing about lists is that they're actually very easy for you to add to a list, remove things from a list, sort a list, etc. So all of these are just kind of properties for why lists are one of the more common used data types in JavaScript. And yeah, so it's an order list that can store multiple values. Arrays can store Arrays can store multiple things, and the way that we access them is with the bracket notation that we've kind of dealt with quite already. The idea is you have an array, and you have a bracket, and in it you put something that JavaScript will try to make into a number, and that number will be the index or the element number in the array. The syntax, once again, things that we've seen before. The open and close bracket indicate like the beginning and the end of the array. And then just by default, every array is separated. The elements in the array are separated by commas. And as we all know, the index of an array starts at 0. Cool. A lot of text here. And then this last part here is something that you will see a lot of, is that whenever we want to iterate through every element in a string or in a list, we always do something .length minus 1, right? And the reason for that is because .length gives you the number of elements, but that assumes we start counting the first element as 1. Whereas in this case, we actually count it as 0, so we actually need to shift everything to the left. Right? So we always do array.length or string.length minus 1. Oh, that was a bit too fast, probably. And then, this is just an example of how we use bracket notation. We've used it, for several problem sets already, so I won't really belabor at this point. The only thing to note here is that you can't access, theoretically speaking, a element that's not in the list. So in this case, this list has only 3 things. But if we try to access the 4th element, or index 3, we go back undefined, right? And that's also very important to know as well, because if you are accessing an array, you see undefined, usually that will tell you, a very specific criteria of why you have that there. And then you can obviously also use the bracket notation to change the elements in the array as well as such. Okay, I know I'm going through this, but hopefully nothing is a surprise so far to anybody, right? Like very basic kind of intuitive understanding of how we deal with arrays. So looping through an array, a for loop is by far the easiest and most common way to loop through an array. And we talked about the for loop syntax yesterday. And here we're just applying to the idea of a list, right? Or to the idea of an array. In this case, the array is people. There's four people in that list, and we usually start at index I equals 0. So we start at the 0th index, so the first element, and we just work our way down. Here you'll see I is less than people.length, which makes sense because there are 4 people, but we'll probably stop when we get to 4, right? So we actually won't count the 4th one. So we're gonna avoid this scenario in which we try to ask for an element that doesn't quite exist. The other way to get around this is you also do I is less than or I is less than or equal to people.length minus 1, right? It's just where do you want to put the plus or minus 1 in, right? It's just very simple math here. And then usually we increment by 1, although there may be scenarios in which you want to increment by more, but for the most part, incrementing by 1 is the most common one. Good so far? Yep. Yep. Okay, nested arrays. So arrays can, like any JavaScript data type can be an element including other arrays. And so what that looks like is, let's say, or oops, well, actually, yeah, we'll go to the example a little bit, but one thing that to kind of talk about is how do we determine what an array is? So the type of operator, if you try to use it for an array, what do you think type of array? If I had an array and I'd use type of on it, what do you think it would give me? Why object? Exactly, right? In JavaScript, any non-primitive type is going to be object, which is actually not that helpful in a lot of cases, right? Because an actual object type is also going to be an object. So is a date, so is a regex, so is a function, right? And so we have a lot of things that can indicate whether or not something is an object. But it's like this, like what all squares are rectangles, but not vice versa. All type of arrays are objects, but not all objects are arrays. So then we have this thing called array.isArray. This first array here in capital, that is like the class, the array class. Much like how earlier we were trying to say, how do you convert something to a Boolean or a number, right? We write a capital number parentheses and we feed in the value. This is similar, a little bit different, but just for now at least, it's somewhat similar in that vein that there is like an array class in JavaScript, like, hey, this is an array. And it has a built-in function called isArray. So if you have something that you want to check to see whether or not it's an array, you literally just pass it through into that function. You literally write array.isArray, parentheses, people. And it'll give you back a Boolean, true or false. That'll tell you is this an array or not. If you want to dig more into the implementation of that function, the documentation online is actually, I didn't think it was that hard to necessarily read. But just kind of at a higher level, know that type of has limitations. Array.isArray is probably your best bet for getting a very easy but precise way of validating whether or not something is an array. Okay, so is everyone familiar with array.push as a way of adding something to the very end of the array? It's the most common one that you use. There's a few other array methods to add things at the beginning of an array, to shift things down, to reverse it, etc. Feel free to Google that. I mean, like, there's a ton of things. I don't want to belabor the point here, but push is the one that you'll see most often, just because it's usually we want to add stuff to an array. Push gets the job done. And in this case, we'll see that ARR is an array with 3 elements, 1, 2, 3. But in line 2, what we're actually doing is we're actually pushing in another element, right? Notice how we're pushing in an array. And it's kind of tricky, right? Because normally you would think, oh, it's 1, 2, 3. I added 2 more elements. Now there should be 5 elements. When in actuality, there's only 4 elements because this 4th element is an array with 2 different things in it, right? So just know that whatever is in this dot push, whatever is in those parentheses, JavaScript is going to see that and think that it's one thing, right? Dot push only works for one thing, right? So even if it's an array, it will add it as a single array, even if that array has multiple things. And obviously here we're verifying that, yep, the 4th element is indeed an array. And then we can actually nest bracket notation as well, right? Because if I'm JavaScript, I get to this part, ARR, okay, that's an array, great. ARR index 3, okay, that's another array. Wow, so I can kind of chain together, right? I can use another level of bracket notation. And now it says, hey, give me the first element in this nested array. And then finally, somewhat confusingly, but you can also kind of understand where it comes from, right? In a lot of ways, strings are very similar to arrays, and that a string is somewhat of a list of numbers. So if you want to get the first letter in the string, we also use bracket notation, right? And we give it an index of the letter that we want to get it at. And so in this case, on this last line, we're just kind of being really fancy here, saying, hey, for the 4th element, which is an array, give us the first element in the array, which is a string, and off of that, give us the first letter, give us the 4th letter, which is T. And that's what we have here. So we can nest together. We can chain the bracket notation to traverse nested arrays. And so here's just an example that there's really no limit to how often you can nest an array. How would we represent a grid in code? This is the answer. Let's just say this big green square of code here is our desired output. In the orange/red text, I'm not sure it's easy to see, right? But what we're really doing is our initial grid is actually just, so in this case, we wanted to create a 10 by 10 grid, right? On line 1 there, the grid, when we start this off, it is just a completely empty array, right? And then we define something called a row, which is another array with 10 elements in it. And so one thing we could definitely do is saying, hey, grid index 0 equals row, grid index 1 equals row, like we write it multiple times over and over again, right? Up until we get to grid index 9 equals row, and now we have a 10 by 10 array of 10 by 10, right? But given how yesterday we talked about dry code, we talked about loops helps us kind of reuse code in a really more elegant and efficient manner. There on line 3 under this for loop part, you actually see we do something very similar to that, right? Where we say, hey, let's start at index 0, let's go up until index equals 9 because it's less than 10, and let's just for each time we do that, let's just push an extra row into the grid. And so when we do that, we get this kind of grid layout in JavaScript. So this is a grid in the sense that, like, to us it looks like a grid. And there's a few, if you want to make a board game or tic-tac-toe game, this would very often be a very common way of doing it. But this is to kind of show you how, when we talk about nesting arrays, right, like, we're not nesting it just because we can't, but because there are some kind of user-friendly features that come along with being able to nest arrays. And then lastly, because this is just a nested array like our previous example, our chain together bracket notation also works just well here. Any questions? Any questions? What? Okay. I mean, and then this last slide. So everything from lines 1 through 7 or 1 through 6 is what we just talked about, right? That's how you create a grid, right? You have an empty array, you have a row, and you just keep pushing rows into it until you get to a certain point and you're happy. So that's what all lines 1 through 6 is. Now the question is, okay, so now I have a 10 by 10 grid. There's 100 things in here, right? And let's say I just wanted to, for something to check all 100 things. I want to make sure that every number in there is valid. Right? How do I do that? Well, we would check it in a very similar way to the way that we created, right? We still want to use a for loop because we're trying to do something a set number of times. And so if you look at this top part here in line 10 there, all we're saying is, hey, let's first get each row in the array, right? Or rather, let's get all the elements in this outer grid array. And so what's grid.length right now? It's 10, right? Because there's 10 nested arrays in this grid array. And so all we're saying is, okay, let's just go through each one of these, and let's, in this for loop, right? So after line 10, we now basically have, so we're going to do line 10, well, I guess we'll do this for loop 10 times, but the really important thing here that the entire purpose of doing this is really to kind of get to this I, right? This I helps us keep track of what number we're on, right? And then, so then inside of it, we can nest in another for loop. And now we actually have a reference to the row that we're looking at, which is just grid index I. And in fact, if we look at it, we actually are saying, hey, grid index I.length, which is also 10, because it's an array of 10 elements. But now we actually have J, right? And J in this case becomes, okay, we know which row I'm in. Now, which element in the row am I in? And so if we nest this for loop on line 10 along this for loop on line 12, we actually have references to I and J, right? I is going to go from 0 to 9. J is going to go from 0 to 9. And between those two, we're going to, if you just multiply those together, right, we actually have access to, we actually have the coordinates, if you will, for every single element in the array. And so in this case, if I run lines 10 through 15, what it's doing is it's actually going to say, okay, I equals 0, right? We're starting at the first element in the array, which is a row of 10 things. Actually, I'm just going to go back to the previous image, probably easier to see, right? In the first part of the loop, we're starting at this first element. I equals 0. Okay, great. I have this element. What do you want me to do with it now? Now I want to go through every single element in this row, right? All 10 things there, and console log out, 0, comma 0, 0, comma 1, 0, comma 2, 0, comma 3, right? Like you're distributing that number across all 10 things. And so after the first iteration of the outer for loop, we should have printed out every single number in this first row. And we're going to do it 9 more times for each of the other 9 rows as well. Conceptually, does this make sense, everyone? Like what we're doing, how we're doing it, how we're using the indexes to essentially act as coordinates for accessing the elements of the array. Are we good? Okay, cool. I mean, that's pretty much it for now. Like I said, this first section is super basic in terms of just kind of getting you up to speed on an array and just getting comfortable around using it. And then let's chat through the questions really quick. Oops, not that one. Chat through the questions really quick. All right. So so in a lot of these functions, or sorry, in a lot of these problem sets, what we're really asking you to do is arrays like strings are very commonly used, and because of that, the JavaScript developers, have made a set of pre-existing tools that make it easy for you, right? Like dot length, for example, or index of, which you already saw, right? In here, all we're really trying to do is asking you to, hey, recreate some of those functions, right? Recreate them so you can kind of understand what's happening behind the scenes, or how someone would choose to implement it. So in the first problem, all we're saying is, hey, do you mind recreating index of, which we saw yesterday, right? When we did the val problem. All this is saying is, hey, if I give you an array, can you tell me if this element is in this array? If it is, give me the index. If it's not, give me -1, right? So the behavior we are already familiar with, so we're just asking you to kind of recreate it. Obviously, don't use index of in your solution. That defeats the purpose. Reverse an array, very similar to, I give you an array, which I just wanted to give me that element, or sorry, that array reversed. The fourth problem is called zoo inventory. What that does is it says, hey, I'm going to give you a nested array, right? It's going to be an array, and it'll have a list of animals, but each animal will actually be its own array because it will have the name of the animal, I think the type of animal it is, and I think its age. So we just want you to kind of go through it and be able to print out, a sentence about the animal, given I gave you 3 different pieces of information about the animal. Array flatten, number 5 here. Array flatter is also, I think the name kind of says a lot, right? Which is like, if I give you a bunch of nested arrays, I give you an array, it has arrays inside of it, it has arrays inside of it, flatten it for me, right? Basically take it through so that you're basically removing all the brackets from this array. So it's just one array with one dimension, and I can traverse it once. So the question now is, for each element when you go through this array, one is you have to decide, is it an array or not? If it's not, then you can just kind of keep the value as is. If it is an array, you need to kind of go into that array to go through and and flatten that. So hopefully, once you work on it, it'll make a little bit more sense. But it is fairly straightforward in that way, right? If I give you a nested array, your job is just take out all the brackets except for the outermost set of brackets. And then the last problem is called make grid. And that's just saying, hey, if I give you 2 numbers, I want a grid, x by y, right? The first argument is going to be x, second argument is y. If I give you, I think, 3 and 4, give me a 3 by 4 grid, right? We saw it earlier with a 10 by 10 grid. We're just asking you to make a function that kind of can take that and customize the grid size. Do the question kind of make sense now, like what we're trying to get you to do with arrays? Okay, great. Awesome. I will select out pairs now, and then we'll get started.
So I think that's blocked right now.
Yeah, I needed to do the pair thing. Second.